Most people have a very muddled image of how the internet operates, i.e., amidst deep-sea creatures and hydrothermal vents. But didn't we develop satellites and wireless technology to transmit signals through the air? Or didn't we move to the cloud? And undersea cable systems, doesn't it sound like a thing of the past? Well, truth be told, the cloud is actually under the ocean and not above it. While it may seem that their fiber optic cables are old technology, they are actually a form of global communication technology that is state-of-the-art. As Jane Stowell, who oversees construction of Google's undersea cable project, said, "People think that data is in the cloud, but it's not, it's in the ocean." Well, stay with us to find out more about it. Hello everyone, welcome to the Technology World, a perfect channel for everything about human evolution and exploration. And in today's video, we're going to tell you about how the internet travels across oceans. So without wasting any moment, let's get started. The internet is entirely composed of tiny bits of code that are transmitted across wires as thin as a strand of hair floating across the ocean floor, all traveling around the globe. Within the time that it takes you to start this video, the data zips from New York to Sydney, from Hong Kong to London, and back again. It is estimated that 750,000 miles of cable already connect the continents to support our insatiable need for communication and entertainment. In the past, companies have typically pooled their resources in order to collaborate on undersea cable projects, like a freeway on which all companies can travel. However, now Google is on its own path, investing in a first-of-its-kind project connecting the US to Chile, home to the company's largest data center in Latin America, through fiber optic cables. It is an exacting and time-consuming process to get it to the destination. In the end, the cable will be delivered to sea on a 456-foot ship named Durable. The cable, however, must first be assembled inside a factory a few hundred yards away in Newington, New Hampshire. This factory, owned by the company Subcom, is filled with specialized machinery used to maintain tension in the wire and to encase it in a protective shell. In the beginning, cables consist of a cluster of strands of very thin glass fibers. Using fiber optic technology, lasers propel data down the threads at speeds close to the speed of light, and on reaching the ground and connecting with a network, the data needed to access an email or open a web page automatically makes its way onto a person's device as soon as they connect to it. Although most of us today experience the internet primarily through Wi-Fi and cell phone data plans, those systems eventually link up with physical cables that allow the transmission of information across continents and oceans. But as part of the manufacturing process, the cables move through high-speed machines that are the size of jet engines, wrapping the wire inside a copper casing that helps keep the data flowing across the line. And depending on where the cable will be installed, plastic, steel, and other materials are added later to make it more resistant to unpredictable ocean environments. When the cables are finished, they will have the same thickness as a thick garden hose at the end. In spite of these considerations, it takes an enormous amount of planning and accuracy to chart a cable route that avoids underwater hazards. Yet the cables must still withstand heavy currents, landslides, earthquakes, and interference from fishing trawlers. However, each cable is expected to last up to 25 years. The cable is moved by a conveyor, which staff members call the cable highway, straight into Durable, docked in the Piscataqua River. When fully loaded, the ship will carry over 4,000 miles of cable, weighing approximately 3,500 metric tons when fully loaded. There is a cavernous tank inside the ship where workers spool the cable. In a circular motion, the cable is walked around by one person as if it were a massive hose, while another person lies down to ensure that the cable doesn't come loose or tangle. Although a team works 24 hours a day, it typically takes 4 to 5 weeks before the ship is loaded with enough cable to reach the open sea. In 1858, the first transatlantic cable was completed, connecting Britain and the United States. In order to mark the occasion, Queen Victoria sent a message to President James Buchanan that took 16 hours to reach him. Even though a number of new wireless and satellite technologies have been developed over the past few decades, cables remain the fastest, most efficient, and least expensive way to send data across the ocean. In addition, it is still far from cheap. Google has declined to disclose the cost of the project to Chile, although experts estimate that subsea cable projects can cost up to $350 million, depending on the length of the cable. Historically, most cables were laid by telecommunications companies, but in the last decade, American tech giants have been taking over to a greater extent. According to Google, at least 14 cables have been backed globally. According to Telegeography, a research firm, Amazon, Facebook, and Microsoft have invested in companies that connect their data centers in North and South America, Asia, Europe, and Africa. However, a number of countries view undersea cable projects as critical infrastructure, and their construction has been a source of geopolitical disputes in recent years. The Australian government intervened last year to prevent a Chinese technology giant Huawei from building a cable to link Australia with the Solomon Islands, out of fear that it would give the Chinese government access to its networks. A ship captain, Jan Durieux, spoke about keeping morale high among his crew during the weeks at sea as one of his most important responsibilities. However, building the infrastructure of our digital world is a labor-intensive job. Aside from the 53 bedrooms and 60 bathrooms, the Durable can accommodate up to 80 crew members. The crew is split into 2 shifts of 12 hours each. There are signs in the hallways warning people to be quiet as someone is always sleeping. However, it is estimated that the ship will carry enough food and supplies to last for at least 60 days. Approximately 200 loaves of bread, 100 gallons of milk, 500 cartons of dozen eggs, 800 pounds of beef, 1,200 pounds of chicken, and 1,800 pounds of rice. In addition to that, there are 300 rolls of paper towels, 500 rolls of toilet paper, 700 bars of soap, and almost 600 pounds of laundry detergent in the room, and there is no alcohol allowed on board the aircraft. Walt Oswald, an experienced technician who has been laying cables on ships for the past 20 years, still gets seasick when he is working at sea. To prevent nausea from getting worse, he sticks a small patch behind his ear. He says, "It's not for everyone." However, bad weather is an unavoidable part of life. It is common for the ship captain to be forced to order the subsea cable to be cut so the ship can move to safer waters when swells reach up to 20 feet high. Once the conditions improve, the ship returns, retrieving the cut cable that has been left attached to a floating buoy, then splicing it again before continuing the expedition. The work on board is slow and plodding. While the ship is at sea for months at a time, it moves along at about 6 miles per hour as the cables are pulled out of the giant basins through openings at the back of the ship. In the areas close to shore, where damage is more likely, an underwater plow is used to bury the cable in the sea floor, where there is a higher risk of damage. The crew at Durable does not expect the work to slow down anytime soon. After completing the Latin America project, Google plans to build a new wire running from Virginia to France that is scheduled to be completed by this year. Miss Stoll of Google, who wears an undersea cable as a necklace, said, "It really is the management of a very complex multi-dimensional chessboard." However, the demand for undersea cables will continue to grow as more businesses turn to cloud computing services for their computing needs. There are other technologies that are on the horizon as well, such as faster artificial intelligence systems and driverless cars, which will also require fast data speeds. And for the first time, more than half the global population is now online, and the United Nations reports that areas that didn't have internet are now getting access. According to Debbie Brask, the vice president at Subcom who is managing the Google project, this is a crucial component of that infrastructure. She says that all the data goes through the undersea cables. But what do you think of this? Tell us in the comments. And that's it for today, guys. We will soon meet you in another exciting video. And if you don't want to miss that video, then subscribe to the channel and press the bell icon. With that being said, see you in the next one. Until then, peace.